Hi everyone. My name is Luis Jonathan. I'm an assistant professor at Innopolis University, and I'm here to present you the AI Snakes Games competition. So, what is the AI Snakes Games competition? It was an it was an educational competitive learning framework experience in order to teach algorithms and artificial intelligence for our students. The organizers of this competition was me. I was the head of the organization committee. Also, Joseph Alexander Brown, the head of the Artificial Intelligence in Games Development Lab. Alexander Grinchenko, bachelor student, third year bachelor student. Selina Varoka, third year bachelor student. What was the objective of the competition? First, let me talk about the objective of the framework of the software that we created and we made it available. So the objective is to create an environment in which students, especially first and second year students of bachelor level courses, they could experiment, they could play, we could exercise, or they could apply the concepts that they haven't seen in courses such as Introduction to Programming, Artificial Intelligence, Machine Learning. So, and have fun at the same time, and also have some competition. In fact, the idea of this game they came during the course of Introduction to Programming to first year students. So along across the course, since the first lab until the very last one, so they developed from the scratch the game. They implemented the full game during the lab activities, and the top of the course of the last lab was exactly to implement basic bots that could play or compete on the game. So it was a very successful experience that we had in Introduction to Programming the last year, and the students just had a blast. They had a lot of fun, and also they they could get in touch with basic AI algorithms and apply them. So let me talk about the general requests or requirements for the game. The programming language was Java. Each two competitors should compete at a time, so they should write a program, a bot in this case, which is a Java class that extends a provided interface. And each bot, in fact, controls one snake, one of the two snakes on a maze, and they should see which snake capture got more apples along 3 minutes. Obviously, if one of the snakes dies during before these 3 minutes, so this snake loses. So the game is very simple. It's a variation of the classic snakes game, but in this case, we have two snakes competing at a time, each snake controlled by a bot. So let's just see details about the rules for the snakes. So a bot control a snake. So we mentioned this can go either north, south, east, or west, but its own snake. Snakes move simultaneously, so at each time, so at each second, the snakes take the decision. The bots that take decision simultaneously without knowing which direction the other bot is going to, and then they move one pixel, so one position in the maze. A snake loses if one of these conditions is attended. If it leaves the board, obviously, if it hits its own body, if it hits the other snake's body, and if it takes more than 1 second to take the decision. In fact, the two threads are running at all time. So each thread, a bot is assigned. A bot runs in this thread, and it has 1 second to process the information, to take the decision, and reinform the game what was the decision. In this case, the direction in which the snake should take. If the bot requires more than 1 second, it loses. So here we have an example, figure one. This figure here illustrates when a snake hits its own body, so it loses. The second picture, the blue snake leaves the board. this picture, a snake, white snake, hits the blue snake on its body, so it loses. The white one loses, I mean. And figure four, head-to-head collision. This is a special case when head-to-head collision, so no snake is to blame, so it's a draw. And apples, since the victory condition is the snake that got more apples, provided both none of them died during the 3 minutes. So the apples appear randomly in an unoccupied cell in a maze. So these are the rules for the game. So obviously the results, if you have two bots competing, so the result is either victory, a draw, or a defeat. And each pair of competitors, in this case each pair of bots, play against each other 5 times. So why not just one? Exactly to enable more robust comparison between the bots. No, why not more than 5? Because of the time constraint. And the format of the competition is round robin, so everybody competes against everybody else. So who participated in the competition? We had Eita Oke from Japan, Team Serpentine from Netherlands, Timo Bertrand for UK, and then we had some representatives from here, Innopolis University, Vladislav Smirnov, Daniel Kabirov, Alexei Zhuchkov, and Vyacheslav Vasilyev. Final results, we computed the number of victories. So we had a significant difference between the first from the remaining. The champion was Eita Aoki from Japan, and the results are available on our website that you can see here. So we encourage you to take a look at the results. There are logs of each match, the result from each match between each pair of competitors. So the results are available. Not just the results, but also a link to a YouTube video where you can watch the competition that was held online. It was streamed online on YouTube. So what you see here is a screenshot, or in fact, it is part of the transmission on YouTube. So as I mentioned before, the competition was happened online, was broadcasted online, and the participants, as you can see also here on the screen, interacted, discussed the algorithms that they could not just watch their bots, not only this, but they could also discuss and also just chat with the other competitors. So it was an amazing experience. It was very exciting, and the participants could interact with each other and enjoy and discuss their techniques, which algorithm they employed, some parameters, while they watched their own bots competing. So it was a great experience, and it was very enjoyable for everybody. So what was the takeaway from the performance of the competitors? Some techniques or heuristics were more utilized by the competitors. We would like to stress the iterative deepening search, which is an algorithm which combines or has characteristics of both the BFS and the DFS. So I'm sure you are familiar with these techniques. And the interesting thing is that the first two places in the competition, the champion one and the run-up, they utilize this algorithm. So this says a lot about the efficiency of the iterative deepening search. Another one characteristic of one of the competitors, the second one, and in fact it was a bit funny to see it happening. It was an apple encirclement, which is in fact when one of the snakes, his snake, was ahead in the apple count of the competitor of the other bot. It starved or prevented the access to the apple by running around it and starving the other snake, preventing it to take apples, and then just waiting for the 3 minutes. So probably in future competitions they should be prevented. But it was interesting to see that he somehow came up with this heuristic, with this strategy, and implemented in its bot. So it was funny to see it happening. and survival prioritization. So uh, the last places in the competition, in fact, the priority was to stay alive and not ignoring the apples. So probably in the future, our students who implemented this strategy should adopt a more aggressive strategy, more apple driven heuristic. So what is the conclusion about our competition? So it was a success experience. We had a lot of fun, obviously, but the most important is during the course of introduction to programming, students were extremely engaged in the course. They were very excited to see in practice what they have seen, and it was fun because it was not just a ludic environment, but also competitive, allow them to compete among themselves. So this was very interesting. And it's a sandbox environment to apply AI algorithms. So recently, for example, I have one student who is working on genetic programming to evolve heuristics, better heuristics, which are human competitive level, that can play in a human competitive level. So future work involves they use not just genetic programming but also artificial intelligence or neural networks, for example, to see how well they perform. So that's all. I encourage you to take a look at in our website. Also watch the video. So it was really fun, and we hope to be able to host this competition the next year and probably adding new challenges, new characteristics to the game. And that's all. So thank you very much for watching it and take care. Bye.